Welcome and thanks for joining us. My guests today are Patrick Meharg. He's the Chief Architect for Model-Based Systems Engineering at Noblis, and Scott James, Senior Scientist at Noblis. Good to have you both with us.
Thank you.
And our topic today is digital twins in the context of digital engineering. And we've got kind of an interesting angle on it because most of the discussions we've had about digital twins concern the engineering and architecture of physical things, ships, submarines, airplanes, whatever the case might be. But we're going to be talking about something a little different, which is how you digital twin and therefore re-engineer and improve and tweak processes. But maybe we should start with a definition of digital twin in the first place. Gentlemen?
Sure. Let me take it here, Pat.
Sure.
Well, I mean, first, you should recognize that the term digital twin has many meanings. As you're kind of indicating, and back in the day, it did originate more from a product point of view, and it was meant to be very specific to a particular product, but it has definitely evolved. But what we consider to be a digital twin is a model which is meant to be kind of a permanent companion to whatever system you're looking at. The idea would be that model would be taking data in at some continual cadence and providing data back out in order to advise and perhaps predict unexpected events with that system.
And what is the nature of the data in a process or a business operation?
That's a great question. So it's really going to depend on the type of twin you're looking at. From a product point of view, you can get very granular. You can be looking at a hardware API and you could be having feedback into something, for instance, that's looking for an overheating element, and that might be in terms of seconds. But from a process, it could depend. For instance, it might be if you have a high enough level process, you might have something where you're looking at reporting mechanisms coming in once a month, which could be manually entered. In between that, you might have things that are going to be scraping out a database that might occur, like, for instance, an hour. So the nature and the temporal cadence of that is going to strongly depend on the questions you want to answer when you make your digital twin.
Interesting. Yeah. So these are fundamentally different than from grown-up wireframe diagrams, you might say, for lack of a better word.
Absolutely. So in the wireframe diagrams, though, are good. I mean, I guess maybe for the process, we might go with flowchart better, would be the kind of the notion here is that, this is going to happen and that's going to happen and so forth. But when we're, again, looking at digital twins, we kind of look at these in terms of a layer stack. So we're trying to combine engineering elements when we do it. So that it will include a requirements layer so that we know from our system, what are the constraints? What are the parameters that we're really trying to do? In between that is going to be the actual model, the simulation, which could be a variety of different things. It could be, for instance, a hand-coded piece, and it could be a domain-specific application. And beyond that is going to be a visual manifestation or a contextual manifestation, the idea of to see what you're doing. And the last part of it, which I think is inherent to the digital twin when we look at it, is the well-defined connectivity back to your original system. So absolutely, it goes beyond wireframes, it goes beyond the flowcharts, and the structure I'm describing is the way we view digital twin.
One key thing I would add too, Scott, is that where the data is originated changes over time. In our concept of digital twins, that what we're trying to build a twin of today may be totally different a year from now. And it gives us that flexibility to bring new data in. And if the data that was used to build that digital twin is no longer applicable, we can also remove that data. So it's constantly in motion. It's changing. And that gives us the flexibility to answer new questions a year from now that we might not even know or exist.
And that's another nature of the digital twin. It's not a one and done. It's not that we make it once and we're finished. It really is meant to live with that system, whatever it is, and evolve. So if the data changes or the natures of it, the questions, that's part of it. So it's I would say it's notional exactly, but it's an evolving entity.
And let's maybe define process, because there are business processes, and Lord knows the federal government has some business processes that are very complicated and they have trouble keeping up with it. Then there's also process industries process. making metal, making gas, moving electricity around. Are we talking about that range of the word process?
I'll take this one, Scott. I think it's both. So how I think about our digital twins is normally there's a process, a business process, a method, procedures that can go through, and we can also build models of those using what we call business process modeling notation, or BPMN, which is a well-known language from a business perspective. But the key is, and then you could have a system, an engine, or a very physical thing. The key there is both of those models now can be tied together in our digital twin, and it gives people that use these processes the ability to look at it from a different perspective. So if I'm on the finance side, I have a digital twin of what the finance model may look like, but they're tied together. So if I'm on the technical side, now we're balancing those things. Are we ahead, behind schedule, those kinds of things.
So how do you put these to work once you construct the digital twin?
So one, there's some enabling capabilities that you're going to need, and we call those digital ecosystems for a very broad term. But really what that does is it comes back to the data. So the data is the focal point. We need to understand what the data is, how it's presented, how we curate it or keep it to make sure it's trustworthy. And then most important is how are the pieces of data connected? When I start to move across what we call a tool chain, how can we connect this data to give you that very rich, immersive digital twin that we're speaking of?
I think another aspect I would add too is that the data is part of it, and probably the most important part of it in terms of the effort. But especially when we're talking a process digital twin, the other X factor is the people involved. So in a product digital twin, to some degree, you're a little bit in luck. The ship's not going to complain. You hook up the digital twin, it just has to send the data back in. But what makes a process digital twin useful is when people use it. So part of that is to make sure that when you are creating whatever this digital twin is, that the stakeholders that may be needing to engage with it at some cadence know where it is, know what it means, and they know the results coming out of it. So as part of that, making sure that that tool is going to be something that people want, and it makes their life easier rather than harder.
And, a traditional model shows how things work. Can you use a digital twin to improve things? I mean, change the process, tweak the process, optimize it. I mean, I would think that's what the goal would be to having it. Fair to say?
To some degree, that's true for any model. But I would say digital twins do excel at that in particular. And the reason is because there is an assumption that that model is going to be current with the state of the system at some level, whatever is appropriate for it. Because of that, you can look at it and say, okay, well, this is my system as of today. So what's going on in the near future? What are trends I'm seeing? And again, if the model doesn't give me some sort of anticipatory feedback, then it's kind of a question why I made it in the first place, other than perhaps just a view of it.
Well, give us some examples.
One place where digital twins is used a lot now, and kind of becoming the common parlance, is airports. In airports, you have a complex system, and when people look at it, they're always mentioning a digital twin for an airport. And what that means, though, is their view of the airport. So there might be a digital twin of the baggage system. And the point being, as baggage are coming in, I know where they is. I know where there's blocks. I might also want to know historically trends of that baggage. Could be people flowing through security checkpoint. That's another good example of a digital twin. Could be the airport maintenance of it. An interesting example now from the FAA is that TFDM just got rolled out. And that program, one of its features is to absorb the arriving and departing aircraft in the airport and its information so that it can manage where airplanes sit, in particular near the gate, so that they don't choke up the surface. And that's what that system does. It's continually receiving information of where planes are coming from, did they depart, and so forth. So what it's done is it's created a process digital twin. It's recording the behavior of the aircraft coming in. And because of that, it is optimizing the system. It's saying, hey, as opposed to everyone just heading out to the runway as soon as possible, wait here so that I can get a lower congestion.
In a sense, then you can look at what the parameters and time values are and figure out where the bottlenecks might be and figure out places where to optimize based on real data from what's happening and not on conjecture.
Right. And at both a micro and macro level. So it could be that you're looking for something very short, say, hey, within the next hour, I want to lower congestion. But it also could be trends of saying, hey, we're seeing this behavior over a longer period of time. And that's another aspect of the digital twin. Because I have a historical record, because I collected data in the first place, it does allow me now to apply higher fidelity and analytics on it to look at different timeframes.
Sounds like a digital twin of the security screening process could be helpful because they're always trying to shave off sometimes fractions of a second per operation or per transaction. And you add that up, it could be hours at the end of the day.
Yeah, absolutely. And just kind of as you're indicating, it could be at the micro, for instance, the individual event of someone being screened or baggage being screened, and then the macro in terms of, how are the lines formed? Where are they going? Do we have enough people getting stuff through? Absolutely.
And by the way, when you have a digital twin of a process, what do you see? I mean, it's easy to visualize a digital twin of something physical, the airplane model and whatever, you turn it in space and stuff and see how it performs. What does a digital twin of a process look like?
Well, it really could vary. So Pat and I were just chatting earlier on today, and we were looking at something what we're calling a mission digital twin. And in that one, for instance, an example, I can have a digital twin of a car or digital twin of an engine, but what about all the cars going around a city? That's another example of a process digital twin. And that one you might look at more like a 3D model or a 3D animation. But another example would be, suppose I was looking at, come back to the airport, the maintenance events in there, and the staffing I would do to be able to make the maintenance. That might look like data analytic charts, right? In terms of them going through it, it would say, hey, when I'm going through this, I can see my curves in terms of these are the maintenance events that have happened. These are the ones I anticipate. This is how long each of them took. And it may end up kind of looking like a Microsoft project. It depends on what's the most useful for the consumers of that data.
Yes, what I'm driving at too, then, I think you've began to answer this. Mm-hmm. This is useful not just to the technologists, but to the people that own the programs responsible for performance of that processor system. It can be rendered such that they can use it personally and say, yeah, we need to do this or we need to do that.
I think that's a key point that you brought up. From an engineering perspective, we're down in the weeds. We're in the nuts and bolts taking a look at things, but the visualization of that digital twin brings the decision maker to light. So conceptually, they're not really interested in the details. It's how does that affect or optimize what I'm trying to do? What decision do I have to make? Can you visualize it for me so I can consume it in a different format instead of lots of numbers that I don't understand? And then from that animation or that digital twin, you can actually say, do you like A or B? And then let's go look, if you choose A, what is the outcome? Watch that visualization, watch the movie, see how it happens, see if it's getting the result that you need. And then so you go look at B, sort of like going to the eye doctor, A, B, A, B. I like this one. So it helps people understand to make that decision quicker.
All right, I think I need a digital twin of my life here that might help things a little bit. But on that note, we're going to take a short break. My guests today are Patrick Meharg. He's the chief architect for model-based systems engineering at Noblis. Scott James is a senior scientist at Noblis. I'm Federal Drive host Tom Temin. This discussion is Tackling Government Challenges Through Science and Technology, sponsored by Noblis here on Federal News Network. Welcome back to our discussion, Tackling Government Challenges Through Science and Technology, sponsored by Noblis here on Federal News Network. My guests today are Patrick Meharg. He is the chief architect for model-based systems engineering at Noblis, and Scott James, Noblis senior scientist. I'm your moderator, Tom Temin. And before the break, we were talking about some use cases for process digital twins. There's another one that I wanted to ask you about, and that is supply chain and the whole supply chain security issue, because this is something that vexes industry and government alike right now. How can digital twins model this, and how can they help?
So that's a great question. From a supply chain perspective, the digital twin can encompass many different processes, and I'll name a couple. So from a pedigree perspective of parts, we're finding in both commercial and DoD fake parts. Fake engine parts, for example, in aircraft. So from a digital twin perspective, now I can start to think about the process of how those parts are actually bought and how are they manufactured and what are the raw materials and how does that go through that manufacturing process. Another key part of those from a process perspective is maybe they're delivered late. So from a digital twin perspective, what is the impact downstream of this process of either a fake part showing up or the part showing up late? How is that going to affect the repair of, and for DoD, maybe chips? I'm waiting on a part and that part's late. So how does it affect everything else that's connected from contractual points of view of being late, also over to production, maybe for repair in a shipyard?
Mm. Yeah, I'll piggyback on the shipyard one since he set me up there for that hat. But there's a use case for the digital twin process in terms of maintenance of ships. So one of the things that we work on is for the U.S. Service Navy. The ships have long life, 30 years, and during that thing they have planned maintenance events. And in those events, they're going to need certain components to be able to execute. There's also complications in terms of the staffing and so forth. But there is a program for harvesting parts of ships after they've gone past their 30 years in terms of once they've gone into their next dry dock and the afterlife and those things come back. And that's an interesting case because coming into, prior to their end of life, there's a supply chain that needs to feed their maintenance events, but then they become the sources for others' supply chains after they retire. And of course, there's other complications for it, but a lot of things are like this now. Digital twins are used as very commonly describe supply chains because they're such a good mental fit. Because we want to know, well, what's it doing now and what are its trends?
Yeah, so I'm thinking, and I think a lot of people listening are thinking, what's the difference between a digital twin of a process and a dashboard? Because for the last 10, 12 years, a lot of agencies have talked about building dashboards into what they're doing to view different parameters in the style of a dashboard.
Yeah, well, I would say, to some degree, they might be the same thing depending on how they build the dashboard. So from the language we would use, we would say the dashboard would be that visualization component of it. And that would stack in with the full notion. So if a dashboard that had live, well-defined data coming into it, if there were requirements for that dashboard saying what the parameters were, and there was some element of a model in between that was taking that data and doing something with it, with predictive, I would say, sure, that's a digital twin. Sometimes dashboards, though, when they're commonly used, they're meant primarily as reporting. So they're primarily taking data passively and putting it back out. That these are in all the years of business processes, they're going to necessarily have a lot of Venn diagrams intersecting. So
sure. And when you engage with a client for the first time, do they generally have a very clear notion of what it is they're trying to accomplish? Because when you get to something like the Navy, each process devolves into 100 other processes, and each of those devolves into 100 processes. And it's a really big enterprise, and involving hundreds of thousands of people and very expensive, as you say, long-lived systems that are composed of dozens and dozens of subsystems. And so how do you zero in on where to apply the digital twin? How do you help people get to a useful point here from something that sounds great until you get to the details?
So usually when we talk about digital twinning and building this process, I usually ask what I call the 20 questions. Really, what are you trying to see, visualize, measure, and scope from that perspective? And then I usually ask, what's the data that you have as an input? So I can't create things if I don't have the information to create them. And then from an output perspective, what is it that you're trying to solve from a question perspective? Usually they have a problem. We're trying to help them visually solve that problem based on good engineering rigor that we can pull back. Then the next thing is, once you solve that problem, who do you need to share that information with? Does this digital twin now become a small part within a larger set of digital twins? Is that something that you're interested in delivering? Because that can drive us in a lot of different ways for what we call interoperability. If I build my digital twin, but only I can use it, it could be helpful for that one situation, but it doesn't go through what we call the life cycle. And that's what Scott mentioned earlier. Our digital twins, we think of it from beginning to end. How can we use this? How can we add things, subtract things, but it's still viable? So we don't have to rinse, repeat, build these digital twins over and over for point solutions.
Sure.
That's
And maybe
advantage
discuss
of-
the other piece of this is the security of the data coming in, and also the security of access to the digital twin, because you've got to make sure that what is evolving and changing as the system ages or changes remains valid and reliable.
Yeah, I mean, that's digital twins are going to have the same issues in terms of any sort of digitization or any time we're putting things up onto the cloud and so forth. The data that was used to create and make the digital twin meaningful may have never been in the same place at the same time. So especially if you're backfitting this into an existing process. So, the great thing is, therefore, hey, I got all the data now. I can really start connecting the pieces. I can go forward. But security becomes a real issue now, because now the dangers of that same information being misused is going to be a problem. And we know ahead of time that's going to be common in any sort of digitization effort of any kind.
Right. So the same access controls, the same cybersecurity controls got to make sure they're there for your digital twin.
Right.
So it doesn't infect the real system, and vice versa.
And vice versa, yeah. And and the better you make it, the more danger you get. That's what with power comes responsibility.
Yeah, interesting. And by the way, how do you build these things? Is there like a digital twin application, and if you have multiple digital twins, how do you make sure they're interoperable if that needs to be the case?
So that's a really great question. There is many tools now that are in what we call in my system engineering toolbox and Scott's visualization toolbox. And what we take a look at is, once again, what are we trying to create, and trying to apply the correct tool to the problem we're trying to solve from that perspective. So I don't believe there is some solutions that it's tip to tail. This one ecosystem contains all those tools, but what we find across DoD, and especially, is they have a lot of these tools, but they're not all from the same vendors. So how do we take what you already have, understand how we're going to move the data, capture that workflow? Data moves from A tool to B tool to C tool to create something, and then how can we connect or disconnect those tools? Because sometimes tools go away. Sometimes vendors, they're no longer in business, or they get bought and absorbed by another tool vendor. So we spend a lot of time. That's part of what we call that 20 questions up front, is what do you already have? What are you using? Let's reuse what you have and add to it.
Right. If you take a look at almost any like enterprise or like simulation environment now, whether it's Unity 3D for gaming or Unreal, I guarantee if you go to their page, you're going to find a big old splash where they do digital twins. Everyone does it because it's a common thing. And so to that point, everyone wants to be in this arena because it's where it's at. But kind of piggybacking to where we were discussing before in terms of, what do when we talk to the client, what does that mean? What digital twin do we build? One thing that's helpful is we're going back to really understand what the actual pain point is. So if the pain point is that they have a really good process and they're really trying to optimize it, well, then the construction of the digital twin is going to be involved and focused on that optimization. But sometimes they just can't see it. And you have a very complex system, and you haven't had all the places in one place at one time. So we might build a dashboard. And then again, underneath the hood is going to be what Pat was talking about. This whole variety of different systems. And, everyone's in it. Amazon's in it. Everyone has Amazon digital twins, Google digital twins. Everyone has it. So there's a lot of tools.
Well, I imagine too that you might know the problem you want to solve, and you build a digital twin and go at it. But I imagine too that a well-constructed digital twin with the right richness of data could reveal things you didn't know, and you discover, wow, there's something to fix.
Absolutely. Yeah. That's a great point. The other thing that we consider is when we create these digital twins, we do a lot of prototyping. So the wireframe, for instance, we'll start and say, is this what you think this thing should look like? And then we get a feedback and we discuss those things, and then iterate. So this digital twin is always in motion. It's always dynamic, being changed, being morphed, being driven in one direction or another.
And I also wanted to ask too, getting back to the example, say, of the Navy with its large physical ships and the airports, because airplane movements are taking place on a tarmac and some infrastructure surrounding that. It sounds like almost there need to be bridges between the physical digital twins and the process digital twins in some cases. Is that a doable functionality?
Absolutely. Although it's to that sense, it's going to depend on the digital twins. So digital twins, for instance, the airport example, you can have a single system with many different digital twins on it because they may be asking different questions. And it might make sense to connect the baggage system digital twin to the security, depending how they're going through, or it might not. The other thing, though, to your point, is that digital twins can be nested. So the point being is if I do have my airport digital twin, I'm also, look, when they build the plane, there's also going to be a digital twin of that. And the question there is going to come to the same problem you get with even when you're building any digital twin is how do you connect the data together? And that's really going to be domain and application specific.
And so a final question, and we have about a minute left. This needs to be a team effort with your data officers, your technology staff, but most importantly, the people that own the process. Fair to say, Pat?
Absolutely. So Scott and I talk a lot about what that organization needs to be. What are the key stakeholders? And at what point in time do we bring those subject matter experts in? The customer is always involved, but like you brought up cyber is a big piece of this. How do we bring and make sure that we're protecting that data? Data scientists, how are we going to organize our data so it's trustable? So we have high trust in the data that we're pulling, and that is it's the latest and the real source of truth. And then the many other disciplines, electrical, mechanical, aero, all those folks have to be involved. So it's a team effort for sure. And Scott and I talk at length about visualization as well, because at the end of the day, usually the purpose and the goal of that digital twin is to share that information with the stakeholder, that decision maker.
All right. Well, some great insight. I want to thank today's guests. Patrick Mayharg is the chief architect for model-based systems engineering at Noblis. Scott James is a senior scientist at Noblis. I'm Federal Drive host Tom Temin. You're listening to Federal News Network. For more on this discussion, please visit federalnewsnetwork.com and search Noblis.